Hello, everyone. Thank you so much for joining us today, and welcome to the informational webinar for the NASA Orbital Alchemy Challenge. I'm your host and MC today, Laura Murphy, Challenge Project Manager, and with me I have Brian Beagle from the NASA Ames Research Center and Jonathan Yakashaw from TechConnect, and they will both speak about the challenge parameters, the purpose, and how you can win. So throughout the webinar, if you would like, please add any questions to the questions box in your GoToWebinar dashboard. We're going to get to as many of those as possible after the presentation. And any that we don't answer during the webinar, we're going to follow up with you directly. Someone from our team will reach out. So you don't have to wait for us to finish speaking or anything like that. Go ahead and add the questions as we go along. And I apologize about our lack of video. We are having webcam technical difficulties with GoToWebinar today, but so you'll just have to visualize what we look like as we speak. But on that note, I would like to hand the mic over to Brian, who's going to go ahead and kick us off today. So go for it, Brian.
Thanks, Laura. Now, I know people usually introduce themselves at the beginning of their talk, but I'm actually going to do that near the end of my remarks. The reason is that in a world dominated by information and ideas, it doesn't really matter so much what your title or credentials are. It matters much more what diverse and defining experiences you've collected and how those experiences shape what you're able to imagine and what you're able to create. So I don't want to put the focus on me. I want to put the focus on the ideas that we're going to talk about today. So the high value we now place on creation and creativity and imagination is really awesome because anyone from anywhere can imagine and create. Anyone can pull ideas and information together and form it into something new and innovative that no one else has envisioned before. And that's exactly the kind of creativity that we're looking for from the broadest diversity of minds out there to help solve this challenge, because it's a tough one. And with that build up, what's the challenge? So it starts with a big question, as this slide says. Finding a solution to this question would advance one of NASA's most ambitious long-term efforts, and that is to create a sustainable human presence beyond Earth, including in Earth orbit and also on other celestial bodies like moons, asteroids, planets, and so on. That's a huge, inspiring, century-long challenge straight out of science fiction. Unfortunately, it could be going better towards meeting that challenge. And why is that? Well, because our wonderful planet that we live on really wants to keep us here. And what I mean by that is that here on Earth, we're in a deep gravity well, and launching ourselves and all of the stuff we need to not just survive, but to live sustainably long-term away from Earth, that would require a massive number of launches. And even with the excellent capabilities of the commercial space industry that's really recently grown, launches are still expensive, limited, and slow. So what does expensive mean? It costs at least $1,000 per pound just to launch something to low Earth orbit. And that's not very far. That's the least we can do to get into space. And perhaps 1,000 times as much as that, on the order of $1 million a pound if we want to get to something to the surface of the moon or Mars. That's a lot of cheddar. So what does limited and slow mean? Suppose this morning I offered market rate funding to whoever could launch my space settlement and all of its inhabitants into geosynchronous orbit. With the current low number of launch sites and launch vehicles, limited payload mass to geo, and long scheduling times, it would take 20 years or more to finish a project like that. And I got to tell you, my space enthusiasts and entrepreneurs, they don't want to wait that long. So, and what about this word dependent? We include in sustainable the goal of humanity being a multi-home species, such that if one of our homes got wrecked, let's say Earth, the others could sustain themselves independently. The International Space Station is kind of our current best effort at pursuing independent living in space. And right now, it requires regular, expensive launches from Earth. The ISS needs supplies of air, food, water, toilet paper, and pretty much everything else we all get from the store or online delivery. But there's no store in space. The ISS gets its supplies delivered by launching them from Earth. And without those supplies, the ISS crew couldn't survive. In other words, with current technology, our space settlements are very dependent on Earth. So we want to try to fix all of those things. And the question is, the big question in this Orbital Alchemy Challenge is part of taking on that launch problem. The question we ask, could orbital recycling of end-of-life spacecraft and orbital debris, could it reduce launches from Earth and enhance beyond Earth sustainability? For example, could we make living beyond Earth less expensive and less dependent on Earth? And if we can, then we can bring science fiction that much closer to reality. So let's change slides. So why would orbital recycling of spacecraft and orbital debris really help with sustainable living and operations in space? It's because the most massive things we need in order to live in space, and therefore the most expensive to launch, are the space structures and infrastructures that make up the living and working spaces for orbital humanity, at least as we imagine them. Right now, we launch these massive modules and systems from Earth at great expense and great energy. When the spacecraft reach their end of life in orbit, we deorbit them into the atmosphere and the ocean, or they remain in orbit as space junk. And then we do it all again. We launch new stuff into space, made with the same materials, until they die, and rinse and repeat. It's really the best we know how to do right now. But back to our big question, can we do better than that if we can figure out how to recycle spacecraft in orbit? Let's look at some key examples and see if all of those spacecraft that are up there really are worth the effort to try to recycle them in orbit into new space assets, instead of repeatedly launching from Earth and deorbiting. The ISS is the biggest thing in orbit at this time, and it has a scheduled end of life in 2030, at which time the plan is to deorbit it, let it burn up in the atmosphere, and deposit it, whatever is left, into the South Pacific Spacecraft Cemetery. Yeah, you heard right. There's actually a name for the place where old spacecraft go to die. But for the ISS, that's 420 metric tons of the same materials like aluminum, titanium, steel, Kevlar, and plastics that we'll use to create new space systems and currently launch them into orbit. So at the current market rate for launches, that's almost $1 billion of value just in launch costs, just for one system up in space, the International Space Station. And that's not to mention the value of the refined space-grade materials that make up the ISS. So what about all the orbital debris we hear about? Well, right now, it's just circling the Earth, waiting for the upper reaches of the atmosphere to slow it down enough to deorbit. Meanwhile, we hope there's no orbital collisions, and we hope it deorbits in a safe place. But if we were able to recycle that 8,000 plus tons of material in orbit, and this is just the dead spacecraft and materials, the reduction in launch cost alone could save tens of billions of dollars. That's 20 times the mass of the ISS. And if we think about all the spacecraft we're launching now at a rapidly increasing pace, with lifetimes that are from months to decades, what if we recycle those in orbit at their end of life instead of deorbiting them, which is what we do now? That would effectively create an ongoing, endless supply of spacecraft-grade materials, again worth tens of billions of dollars just in the reduced launch costs. So next slide. So what if we, with those driving examples, we can really make a mental shift that allows us to answer our big question. So what if we stop treating orbital end-of-life spacecraft as a problem, specifically as trash that we have to throw away, and we start thinking about end-of-life spacecraft as a multi-billion dollar, actually multi-tens of billions of dollar resource for manufacturing future space systems? If we could develop the technology, the orbital recycling technologies and processes, we could dramatically reduce the expense, delay, and dependence on Earth of living and working in space. We'd get that much closer to sustainable life on Earth. But creating such on-orbit recycling technology will really require a pretty giant leap for mankind. It's a tough challenge, and this challenge is really the first step in that direction. So next slide. All right, so here we're getting down to really the challenge of that we're going to respond to. The challenge goal is just as it says on the slide, to explore whether on-orbit recycling of end-of-life spacecraft and orbital debris can really be cost-effective compared to launching Earth-manufactured spacecraft. To make this challenge big but not too big, we're limiting the scope to recycling already captured space assets. So you've got a spacecraft in hand, whether it's spacecraft or orbital debris, really, into material feedstocks. So we're just doing that piece of the problem of going from, let's say, a dead spacecraft to a new one in orbit. So within scope is the steps of recycling into feedstocks, and that includes what we call safing. That's removing liquids, gases, and electrical energy so there's no RUD, which is rapid unintended disassembly, more commonly known as an explosion. So you really want to prevent that. So the first thing you typically do is to get rid of all the things that could cause those kinds of problems. Also, disassembly of the spacecraft is in scope, material separation and cleaning, feedstock forming, and storage. Explicitly out of scope, for this challenge at least, are recycler launch. So if you have a recycling system and the launch piece, that's out of scope. We don't need to talk about it. Orbital asset capture. So again, we're assuming that you've kind of captured the spacecraft that you want to recycle. And we're keeping out of scope the future space asset manufacturing. So we end up with feedstocks, and we're not going to talk about, or you don't need to talk about space asset manufacturing with those feedstocks. However, your proposal can talk about those things if it makes your solution more compelling, but really make sure to talk about the things that are in scope first. And if you have space and you really want to talk about, how awesome it would be and what you'd want to make with these feedstocks or other aspects that are out of scope but related, you can do that if you have space in your page limit. All right, next slide. So here's a graphic depicting what I just said about the scope. So it includes the steps of recycling a spacecraft into feedstocks, and that's in the orange box or the salmon colored box there, but not associated processes such as, again, recycler launch, that's down below, capture of the space asset, that's upper left, and eventual use of feedstocks, that's upper right, and there's other things that are in the blue boxes. So those things are out of scope. You're welcome to talk about them if you wish and you have space, but we don't need to. All right, I'll give you a few seconds to look at that. And then next slide. All right, this is really my final slide before I hand the virtual microphone over to my colleague. But I want to directly answer a question you may have, which is why we're using crowdsourcing to answer such a big question. I mean, why doesn't NASA use its regular programs and projects to explore and answer a question like this? And we've listed a number of reasons for that. First, beyond Earth sustainability is really a long-range, complex challenge that requires exploration of a diversity of ideas, approaches, and technologies. And also the full solution, it's going to be a combination of those diverse creative ideas and advanced technologies, probably almost certainly from multiple sources. It's unlikely that any one source is going to be able to produce a full recycling system. So it's not just a single technology and done. And besides matching those characteristics, crowdsourcing is also a great approach because it allows NASA to focus our in-house staff on the plan of record. And unfortunately for the ISS, the best we can do really is to deorbit it safely. But so NASA focuses on that while also sponsoring exploration of others to look at more forward-leaning ideas, more innovative approaches or ideas. And in short, crowdsourcing is really a fast, efficient method for finding the diversity of inputs required for this kind of challenge. A final reason for crowdsourcing is NASA's strong support for this mode of ideation through our Space Technology Mission Directorate, which sponsors the NASA Tournament Lab, and that's where this challenge arose from. NTL uses crowdsourcing to tackle all sorts of NASA challenges. It collects interesting challenge ideas by periodically crowdsourcing internally from all NASA employees. And I happened to read an article about the planned deorbit of the ISS. And also, I read about the plan for NASA to start using commercial space stations after the ISS. And so immediately I thought, wait a minute, the materials of the ISS are like gold in orbit. But the second they drop out of orbit, the second that you can no longer keep those materials in orbit, they become absolutely worthless. And So the question in my mind was, can all of us, I don't have the background to develop in orbit recycling, but can all of us imagine the technology to mine that gold in orbit and make it much more sustainable, make the ISS really much more valuable overall to NASA and to mankind, and make it possible for sustainable living in space? So I've approached the end of my remarks, and I said I would say something about myself. I happen to be on the leadership team of the Exploration Technology Directorate at NASA Ames Research Center. This directorate, it's the biggest at Ames. It has almost 1,000 civil servants and contractors conducting NASA-funded research in aerospace and space science, earth science. We're also developing aerospace-related technologies and operating facilities that support NASA's mission. But more important than that, I could literally be anyone at NASA and have dreamed up the Orbital Alchemy Challenge. That's the way these internal crowdsourcings work at NASA. You can be anyone from anywhere, and you can come up with creative ideas that NASA wants to fund and explore. And so that's what I did. And in exactly the same way, literally any of you could come up with the best orbital alchemy solutions and win one of the prizes. And I hope you do. So together we make living beyond Earth accessible and sustainable enough for all of us to experience it. I wouldn't mind doing that for at least a little while. Such a defining experience of living in space, even for a little while, that would definitely shape what we could imagine and what we could aspire to create and accomplish in our lives. Those are the kind of experiences that shape us. And so with that, I'd like to hand the mic over to my colleague Jonathan to talk about the logistics of the Orbital Alchemy Challenge, and also just to remind you to put your questions in the chat window. Thanks.
All right, thank you, Brian. Thank you both for the details of the challenge and also for the inspiration for participating in the challenge. So with that in mind, let's talk about how your responses will be evaluated. First off, it's got to be in scope. And since, as Brian was just saying, we're focused on technologies for recycling spacecraft, you're going to need to propose at least one of the recycling steps that Brian mentioned for at least one of the materials while in orbit. Now, if your approach can combine multiple recycling steps or be responsible for multiple different materials, that's great. As Brian also referenced, any proposed technology has to be cost effective. Now, there are a number of different ways to consider that criteria. Your approach could be cost effective if it can process more mass than itself, or can perform multiple different recycling steps, or handle multiple different kinds of materials. There are lots of different materials that could be harvested from orbiting spacecraft, anything like aluminum, titanium, steel, plastics, ceramics, residual fuels, volatile gases, or liquids. All of those would be really great targets for recycling. One other important aspect of cost effectiveness is the level of support that is required. You can reduce your costs, or excuse me, if you reduce your costs, you will reduce the amount of support that is needed from Earth, and therefore your approach will be more cost effective. One other consideration for cost effectiveness is if your recycler can handle multiple different targets of different sizes, different physical configurations, what have you. In short, the more adaptable your technology is, the more likely it is to be cost effective. Obviously, your technology should be safe. We want to avoid that RUD, as Brian was just saying. Now, we're not talking about safety for astronauts, but it's still crucial. Your recycling technology shouldn't create new dangers, either for the recycling technology, for the target being recycled, or for any other objects in space. And to that point, we don't want to create any new space debris. So please keep that in mind in your response. A frequent question is how well developed a technology has to be in order for it to be considered for this particular challenge. Ideally, any proposed technology should be ready for testing in 2030. Now, that being said, Conceptual and early stage technologies are still welcome to be submitted. We're interested in seeing all of the technologies that could recycle spacecraft while in orbit. And lastly, we want to know what makes your approach innovative, unique, different from other concepts. So be sure to give that some thought when you're composing your response. So let's talk about the criteria and the points associated with them. On your screen right now, you can see the scoring metrics that will be used to evaluate responses. We're looking for responses that present compelling technical details, information about the cost effectiveness of the proposed technology, and its associated safety. Again, avoiding that RUD. We're also looking for information on how well developed your technology is, and also what makes it unique. And finally, your response should present clearly relevant information about your technology. At the end of reading your response, you want the judges to have a really phenomenal understanding of what it is that you envision for your recycling technology and what it's going to do while in orbit. Let's talk prizes. So there is a great mix of financial and non-financial awards available as a result of participating in this particular challenge. First off, we'll talk about the financial ones. The first place prize will be awarded $25,000. There is one second place prize for $10,000, looking at up to 3 third place prizes at $5,000 each, as well as up to 5 honorable mention prizes at $1,000 each. In terms of the non-financial prizes, up to 15 respondents will be invited to pitch their idea at the Defense TechConnect Innovation Summit in Washington, D.C. this fall. This is an annual conference hosted by TechConnect and is well attended by experts and industry professionals. If you're interested in learning more about that challenge, you can access that information on the awards tab of the challenge page. There is also the potential for connections to and introductions to technical accelerators like SBIR and STTR, developers and manufacturers, as well as opportunities to speak at or attend other conferences. Like I said, all in all, a good mix of financial and non-financial awards and incentives here. Before I proceed from prizes, I just want to say that we are aware that some of you might not be able to accept a monetary prize as a result of rules within your organization. For those of you in that camp, we do have a parallel path that will still allow you to participate, win, and even pitch at the Defense TechConnect Summit this fall, all while retaining all of the rights to your submission. It's very simple. All you have to do is select that option on your participation agreement, and I will be getting to that in just a moment, indicating that you are intending to forego all cash prizes. We've taken some time to set up this option so that any organizations and individuals who are interested in participating in this challenge can do so. If you think that your organization has restrictions that might prohibit you from accepting a cash prize, we strongly recommend that you consult with the relevant individual or department in your organization to make a determination before you submit your response. The reason being that once you submit your response, that decision regarding the acceptance or rejection of a cash prize is permanent. So please keep that in mind when you're preparing your response. Okay, so who's eligible to participate in this challenge? As Brian said, as part of his remarks, we're really looking for a diversity of respondents for this challenge. And with that in mind, we are interested in students from elementary to middle school to high school to university students. You're all eligible to participate. Speaking of universities, university researchers, you're also welcome to participate. If you've got a team together, whether that is a corporate entity or just a group of interested citizen scientists, please consider responding. We would love to hear from you. This challenge is not closed to is not closed to international responses. We are looking for responses from around the globe. As Brian said, it's unlikely that a single solution is going to be able to address all possible scenarios. So we're looking for as many different responses from as wide a pool as possible. So if you're interested in responding, please consider doing so. We would love to hear from you. One caveat to that, please be sure that your local regulations don't prohibit you from participating in this particular challenge. Okay, now that we've heard about the who and the what of participation, let me talk for a little bit about the how of participation. First and foremost is the challenge website. The URL is up on your screen right now. It's NASA Orbital Alchemy.TechConnectVentures.com. In addition to the fact that it's got a wealth of really great information for you that you're going to want to keep in mind as you're working on your response, that is where you're going to need to submit your response. So it's a very important location. Speaking of that submission, there are a few components that need to be included in your response. You're going to need to complete that participation agreement, which will indicate your interest in or rejection of cash prizes. You're also going to need to be able to provide evidence of eligibility, and we've got more details about that on the challenge page. Essentially, it's indicating your citizenship for the challenge. The lion's share of your response is going to be your technical paper. You have the option of using the available templated technical paper that we have offered on the challenge page, or creating your own. Either way, this document is going to be the main repository of information for your approach, what it does, what it can recycle, what have you. It can be all text if you want. If you would like to include images with your response, you are certainly welcome to do so. Please bear in mind, there is a page limit on your technical paper, 8 pages maximum. That includes any graphics that you have as well. The reason being, we're not looking for novel length presentations, but really just a high level overview of your response. I should also say that that page limit does not include the contact information and participation information that you have to include. It's just the technical content. In addition to your technical paper, you have the opportunity to include a brief 1-minute long video with your submission. Entirely optional, whether you include it or not, that is up to you. It could be an introduction to your team. It could be an animation of your technology in action. Whatever you want to include is up to you. I would just suggest that whatever you include, it support your overall proposal. And speaking of what to consider when composing your response and what to include, I strongly recommend taking a look at the scoring metrics that I shared earlier. Make sure that whatever you include, that it aligns well with those metrics. And if it doesn't align with those metrics, don't include it. I think the single greatest piece of advice I can give you when it comes to composing your response is this. You're telling the judges a story about your technology. So make it a good one. Make it clear, make it compelling, make it concise. And my final note on participation is a very important one, the submission deadline. All responses have to be submitted online through the challenge page by Friday, May 27th, 2022 at 8 p.m. Eastern Time. Since this is a challenge and a contest, we are not able to accept late submissions. So one final recommendation for you is that you submit as early as possible to make sure that you don't run into that deadline. Now, in just a little bit, we're going to get to the questions that you all have been submitting throughout this webinar, and I'm looking forward to seeing what questions you have. That being said, We do have multiple mechanisms set up and in place for you to ask questions outside of today's webinar. On your screen, you've got an email address and a phone number first off. The phone number is area code 843-760-4337. And the email address is challenge@techconnectventures.com. Either one of those will be great to get to me. Ask your questions, let me know what you've got on your mind, and I will do my best to get you the information that you are looking for. Additionally, we have set up 3 separate office hours that will be hosted in the coming weeks, 1 next week and 2 more in May. And we have scheduled these office hours in the morning, midday, and in the evening to make them as available as possible to as much of the world as possible. The first office hour session will be April 21st at 8 a.m. Eastern. The second is May 5th at noon. And the final one, the Monday prior to the submission deadline, is at 8 p.m. Eastern Time. We'll have a link on the website for the office hours, and it'll also be included in email notifications as well. I won't be presenting new information during these office hours, but it is intended to be a resource for you to ask questions outside of today's webinar. And so I look forward to hearing the questions that you've got there. With that, I'm going to turn everything back over to Laura. Laura, let's see what questions people have been submitting.
Okay, great. We've got a few that have come in. So the first one comes from Julia, and she asks, the technical maturity is determined by NASA's TRL scale. However, some TRLs require testing and system verification. So how should I proceed with the challenge?
That's a really great question.
Which one?
Oh, go ahead, Brian.
Yeah, I think, so you'll know where your technology is. We're not expecting during the preparation of your technical paper or your response to this challenge that you're going to do a huge amount of technology development. You're going to be either presenting notional ideas, which are going to be a low TRL, maybe TRL 1, or something that you've started to put together into into a system that could work in orbit. Maybe you'll be up to TRL 2 and so on. So again, we're not expecting you to do technology development in the month and a half or so that you have before the submission deadline.
Okay, great, thank you.
I think the only thing I'll add is that if you're already working in this space and you've got developmental information that you have already obtained, that could be great information to include in your response. But as Brian said, we're not expecting you to do new research in the time allotted.
Okay, great. We have a question now from Adrian, and Adrian asks, is it assumed that we will know what the to-be recycled spacecraft are made of, not just generically, but the material composition of every nut and bolt? Or is scouting that out part of the challenge?
So Laura, I'll look to you. I don't think we've put, we have some links for a few spacecraft types, and I think those are on the website for examples. But I'm not sure how detailed that information is. So we can look at that and see whether we can provide links with more detailed information about what a typical spacecraft would be composed of.
Yeah, and I think from conversations, we've talked about this being, as you mentioned, a typical spacecraft. You provided several examples of that. We're not talking about one specific spacecraft and what it's made of. So I think, Adrian, to answer your question, we'll provide you with what some of those materials often are, but it's not going to be every nut and bolt of any specific spacecraft. So Jonathan, do you have anything to add to that?
Actually, kind of a follow-up question. I suppose, Brian, that interested respondents could formulate their response as if it was recycling a particular satellite spacecraft in mind, yeah? basically saying, for my paper, I'm going to propose recycling spacecraft X, and this is how I'm going to go about doing it.
Yeah, one could certainly do that, and in that case, if you really want to focus on a particular spacecraft, then it's probably going to be part of your response to research the construction and the materials of that spacecraft. But most people are probably going to keep their response. I'm just speculating here at a higher level, a more general level about how they would go about the process of one or more of those recycling steps, and might not select a particular spacecraft.
Okay, great, thank you. All right, so let's see here. So one question comes from Francisco about the scope of the challenge. It says, as the scope of the challenge does not include capturing the spacecraft, do we consider at the starting point of the process that the spacecraft is latched to the outside of the recycler, or do we consider it is already inside of the recycler? What is, in other words, what is the status of the actual recyclable craft, and what's their responsibility to speak to that?
Yeah, I think we've said in the frequently asked questions on the website that the target of recycling is in position to begin the recycling process. So if you have, if that's a container for you, then the spacecraft could be inside your container. If it's some external approach, then it's latched on. So you can consider that the spacecraft is where it needs to be to begin the recycling step that you're focused on, steps.
Okay, great, thank you. All right, we have another one here. Let's see. One second. Sorry, it's loading funny. Okay, a question from Adrian. It is more profitable for NASA's contractors to manufacture systems entirely on Earth, as they have always done. Why would they take advantage of feedstocks in orbit when it costs them potential profit to do so?
Yep. So this is the role of the disruptor, essentially. So you're basically saying that the current space industry is not likely to change their model because it's so hard to do, but it's likely to be some disruptive company, some other company that comes in and says, I think I can undercut you. I think I can provide the same service that you do at a lower cost, or provide a different service. So for example, you might imagine that building something in space could be very different than something you built on Earth and launched from Earth. And so it may be a company that's not currently in the space industry market.
And Brian, correct me if I'm wrong, there's also the potential for increasing numbers of missions and opportunities, because of the costs involved with launching from Earth, whether that's material costs or people costs or what have you, fuel costs. If you have the opportunity to do more missions, that could be an exciting incentive to adjust your business model.
Yeah.
Right. All right, we have another question. Who specifically is the customer for this recycling effort, and what specific use would they have for the recycled materials? The desired end state of the product determines what recycling methods are viable.
So for this challenge, we're asking you to look at the very largest systems in orbit and create the most mass that you possibly can, because we're trying to see if it's viable to create a new kind of industry in space, an industry where we are manufacturing spacecraft in orbit. And that takes a lot of mass, and to make it cost competitive, much less cost advantageous to building something on Earth and launching it from Earth, we've got to have launches have to be expensive. and that means we're launching a lot of mass. So we're talking about the targets being the largest ones in orbit and being able to recycle huge amounts of mass. So I guess that's the first part of that answer. I think I may have missed some part of that response. So can you repeat the question, Laura?
Yeah, just wondering who is the end customer, and that would affect, you know, their potential use. What would that be so that they know how to tailor their response?
So actually the end customer for this, there may be two end customers, but it may be just NASA. So what I imagine happening after this challenge, because we were really talking about we're talking about low TRL, you know, early conceptual ideas. And the next step may be that NASA has a small business innovation research topic about this, or the Space Technology Mission Directorate develops a program to explore further. So it might be NASA that's sort of the recipient of the information we develop. I'm sorry about the loud noise outside here, but NASA may be the recipient of the information that comes from this challenge. It could be, though, that some company says, I'm not waiting for NASA to develop the technology more. I'm going to do it myself, and I'm going to propose, you know, to create feedstocks for. It could be small scale initially, and it could be, you know, people just want to build something in the ISS or in, you know, a new commercial space station that wants feedstocks or something. So it could start in that way. Or maybe a company says, nope, I'm going all the way and I want huge amounts of feedstocks and I want to build my, you know, my really innovative structures in orbit because there's no way I can launch what I want from the ground. So there really, it could be any of that range of kind of customers for the information that we're developing here. We're not really developing technology at this point. We're developing kind of information about what is viable and how it might actually work.
Okay, thank you. So going back a little bit, just to discuss some terminology, one of our questions is, what do you mean by feedstock? So can you speak a bit more about that?
Yeah, so this is this term has come from the 3D printing and the that digital manufacturing kind of realm. It's become more common from that, but it's essentially raw materials that we can put into advanced manufacturing. Typically, that's at least the way that we think about it now, and that's the way that I'm thinking about it in this from this challenge. Is that there will be some advanced manufacturing methods which allow you to take kind of raw materials, big bulk raw materials, and put those on, add those to an existing structure, kind of layer by layer or element by element, to create the full structure or system that you want. So that's kind of what feedstocks are. They're something that you can put into a manufacturing process, and I think of at least the advanced manufacturing processes, which are especially in orbit, they're going to have to be pretty low energy, and so you're not using metal forges and things like that. You're using more advanced manufacturing methods. Hopefully that answered the question.
Sorry, I thought I was off mute. Yes, thank you. Can you also tell me a little bit more about how pure the recycled products have to be? This is a question from Alexander.
Yeah, and that's not something that I can really say. I don't have the expertise in that area. You would want them to be as pure as the material that you're sort of drawing from. So let's say you're recycling aluminum on the international that is part of the International Space Station. Just as an example, you'd want it to be as pure as that aluminum that went into that that space station, so that it's space grade and can be immediately used for manufacturing of a new spacecraft. But I could also imagine that there are different uses, you know, than than just creating the same system, the same kind of structure that you started from. So this could be part of your response to say what you might envision it being made of, if you think that the purity is less, or if you think that purity is more than what you started with, is better. It could be part of your response to say why you think that the feedstock you're producing is valuable.
Okay, great, thank you. Julia asks, how do we get the precise spacecraft's physical dimensions from the template? So again, we kind of have a question about a really specific, we talked about the nuts and bolts and the materials. This is a similar question. How would you answer that, Brian?
Yeah, I think my answer is going to be the same. If you've chosen a particular spacecraft, I mean, we're not going to be able to tell you about all the spacecraft that are up there. So if you want to target a particular spacecraft, you're probably going to want to do some research on how it's constructed, what materials, and how you might take that apart and recycle it. So I think that may be part of the respondents' actions and effort to figure out those details about a particular spacecraft.
Yes, and since this is an ideation challenge more than a technical one, we're definitely looking for viable, technical thought here, but not providing specs and dimensions as part of this. So hopefully that helps, Julia, in your question. Another question comes from Gregory. Is there a mechanism for interested parties to combine ideas and collaborate on a single entry as a team? And then he goes on to say, for example, people in this webinar, or other people who have skill sets, how can they contact each other and maybe work together? Jonathan, will you speak to that?
Sure. Unfortunately, we don't have a particularly good way for you to collaborate on the challenge page. That being said, you're going to know what your relative strengths are when it comes to this challenge, and where you may be in need of a teammate. So if you're interested in reaching out to individuals and organizations, I would start there. Figure out where you might need the most assistance with your response, and then find individuals and organizations that might be able to contribute to it. As I said, you are more than welcome to collaborate with other teams or other individuals to make your response as strong as possible.
Great. I have a question from, let's go with Tina. Can we volatile organic gas and helium to make a new fuel?
Yes. So you can certainly, one of the steps, if you want to talk about safing, if that's part of your response, recycling, storing the volatiles, either the liquids and gases, that's a valuable thing to do. Those are definitely valuable in orbit. They would have to be launched from Earth if you needed that. So yeah, if you want to talk about the value of the things you're recycling, and that could be the volatiles, this is one of the things you can do in your response.
Okay, thank you. Let's see, one question from Christopher. What kind of propulsion are you looking for?
So in this challenge, we talked about, the idea of, what moving things around in orbit. So either let's say you want to capture a particular spacecraft or a piece of orbital debris and recycle that. You could talk about how to move that to the recycler, but like I said, that's kind of out of scope of this challenge. The one place where you might want to move things around, let's say your system is multifaceted. You have a recycler piece and you have a storage piece, and you want to get feedstocks from the recycler to the storage, and those are in slightly different locations. You may you may want to talk about how you do that. And that's up to you. You decide how you imagine that happening, or how you would engineer that to happen. Hopefully that answers the question. Laura, if you're talking, we're not hearing you.
Can you hear me now?
Yes.
Okay, I can hear you. I don't know why, but I got kicked out, y'all. I can hear you, but I can't see our dashboard, so I'm not able to continue with questions, unfortunately. Let me see if I can get it to pop up again.
While Laura is checking out the questions, please go ahead and continue to submit your questions, even if she can't see them right now. As we had indicated previously, all of the questions that get submitted during today's webinar will get answered, whether they are answered live or offline. We will provide you the information that you're seeking. So don't let this little technical hiccup prevent you from submitting your questions.
So Jonathan, one thing I noticed on the website is there's a contact information. I know we don't have a good way of helping people form teams, but this might be one way to help people say, I'm looking for such and such type of capability, or and I don't know who else is interested in this challenge. I don't know if we would do matchmaking. But how do those messages, I presume that we essentially just respond to those messages directly to the person who asked it, rather than post, unless it's a frequently asked question.
Yeah, the contact form that is on the challenge page is typically for asking questions about the challenge. If it's a highly specific question, it would go back to that individual who submitted the question. If it seems like it's a question that's been asked a lot, or seems like it would be good information for all interested parties to know about, that would be something that we could add to the FAQ page. Not generally used for facilitating team building.
Got it.
Okay, guys, I'm back and I can see questions. Sorry about that. One more. We've got a few more minutes here. So this one's from Stephen, and Stephen asks, does a submission remove intellectual ownership of the idea? So Jonathan, do you want to speak to that?
Sure. So there are a couple of different pathways here, and I alluded to one of them previously. If you submit an idea and you accept a financial prize as a result of participation in the challenge, you are turning over the right to that idea to NASA, so that they could do something with that in the future if they wanted to. If you wanted to retain the right to that idea, then you would have to forego the cash prize. And on the participation agreement, that's where you would indicate whether you are accepting or rejecting the cash prize. So if you work for an organization that is maybe working along these lines and you want to retain the right to that idea, then you would likely need to forego any cash prize. As I said, if you forego a cash prize, you are still eligible to participate, still eligible to win the challenge, and still eligible to be invited to pitch at the fall event. I hope that answers your question.
Okay, great, thank you. Let's see. Here's a question from Jared. Many of the truly innovative systems for lowering cost of launch are extremely complex. A very long road would need to be undertaken to develop such technology. If we had something that was truly innovative and a totally different way to attack the problem, how would that first step be taken?
So I think I need you to repeat the question. I think it's for me, and I think I need to hear it one
Yeah,
more
it's
time.
okay. It's okay. It says many of the truly innovative systems for lowering cost of launch are extremely complex. It's a very long road which would need to be undertaken to develop such technology. So much money, so much time. If we had something that was truly innovative in that it was totally different, it's a totally different way to attack the problem, what would the first step be that they would need to take?
So yeah, this is what I thought. The question really is focusing on launch, and this that's out of scope for this challenge. We're trying to sidestep launch. We're trying to not do launches by this challenge. So what we're trying to do is say, I've already got, this kind of gold mine of materials, space grade materials in space, and all I'm doing with it right now is dumping it back into Earth and into the atmosphere and into the ocean. And then I have to launch again. So that's the problem. We have these very expensive launches. It's very hard to innovate and create, reduced launch costs. And instead of trying to do that, let's use the resources we already have in orbit. Just keep them there instead of deorbiting them. Keep them there, turn them into feedstocks for the stuff that I would have launched very expensively. Instead, just build that in space, or even better, build something that I really wanted instead of the only thing that I can afford or can fit in a launch vehicle and launch up there. Instead, I could build something completely different in space and avoid launches altogether. So that's the way that we're reducing launch costs, is by not launching.
Okay, great. One question from Jared. How many tons does the speaker imagine a reprocessing facility will weigh?
I don't have it could vary from very small to huge. So let's say that your goal was to provide feedstocks for smaller things on an existing spacecraft. You might have a pretty small low power recycler, and that was your goal, to just show that size of recycling could be done. Whereas someone else might say, I want to be able to recycle the full size of a module on the ISS. And so they've got a huge containment vessel, and they're pulling in a full ISS module, and they're going to work that over inside their containment module. So again, it could vary from small to large, depending on what you think is possible in the 2030 timeframe, or whatever timeframe you're targeting. Where your expertise is, what you think would be really compelling for us to see. There's a lot of things that are going to go into your decision of what scale, and therefore what mass you'd want to try to launch into orbit and demonstrate and imagine. So there's no way I can bound that for you. You're just going to have to do it based on your expertise, your imagination, what you think is going to be a compelling story for you to tell.
Okay, great. We have just a couple more minutes if anyone else has questions they want to put forth. We have one more though for Jonathan. Troy asks, is there an expected announcement period for the awards?
Well, the glib answer is before September, when the pitch event will happen, but it's dependent on the ability of the judges to read and review and score all of the submissions that come in. I believe we are, because we're closing in late May, we would need probably a few weeks to go through all of the submissions that come in. I think probably looking in, and Laura, Brian, correct me if I'm wrong here, but I think probably somewhere in the early to mid, late June, maybe early July time frame. That
So
sound
we
reasonable
actually,
to the both of you?
yeah, we do begin judging, as you mentioned, in May, but we actually announce the winners publicly July 25th. So you'll know sooner than that whether you you have been chosen, and you'll confirm your award, your winner status. But we will announce publicly in late July. So I think the combination of what Jonathan was saying, but you can also read more about that in the rules section on the website.
Thank you for remembering the date, Laura.
I did not, but I went and found it while you spoke.
Either way.
Hopefully that answers your question, Floy. All right, let's see. Another question comes in. Is there any particular method to capture debris for recycling, or is this also part of the proposal? And I think we've had a couple more questions about capture. I know you've spoken to that, Brian, but as a closing note, can you speak to that?
Yeah, so once again, capture of either a spacecraft or debris is outside of the scope of this challenge. If you wish to include it in your response, you can do that if space allows, but remember, since it's outside the scope, it's going to contribute less to your score than if you really target what's in the scope of the challenge.
All right, on that note, we are at time. I just want to thank both of our speakers today and all of you for joining us. And we look forward to seeing what you submit in the coming months. And we'll also publish links so you can join office hours and do this again with Jonathan in the next few weeks if you'd like to speak more in detail about your proposal. So thank you, everyone. Hope you have a great rest of your day.
Thanks.
Thanks.